Hello everyone, my name is Krishna and I am doing my Masters in Mathematics from IIT Open. Today we will be discussing very interesting and fundamental topic of geometry, locus. In this lecture we will be studying definition of the locus, we will try to visualize it by an example and we will also learn how to write the equation of a locus. And then we will apply all this concept doing Ajay Malik's previous question. Let's start by writing the definition of locus is a path traced by a moving point. How this point moves? When point moves under given geometrical condition. The point moves according to a geometrical condition. Let's try to understand and visualize this definition by an example. Suppose this is an xy plane. Here are two fixed points A and B. I want to make my point move under a geometrical condition. The geometrical condition that I am imposing on the moving point is that it should be always equidistant from these two fixed points A and B. The obvious location of that moving point would be midpoint of this line segment. Let's say M. Because this will be equidistant from both the points A and B. Now let's assume any point in the plane P, which is I am assuming to be equidistant from A and from B. If I join these points P and M, then two triangles are formed PAM and triangle PAB. Seeing these triangles, these two sides are equal because of our assumption. These two sides are also equal because AM is equals, these sides are equal, PA is equals to PB due to assumption. AM is equals to MB since M is midpoint and PM is equals to PM, common side. I can say that these two triangles are congruent by SSS criteria. Since these triangles have been proved congruent, then I can say that these two angles are equal. But since we know that angle formed on a straight line is 180 degree, then I can say that this angle is 90 degree. The conclusion here drawn is here that if I take any point in the plane which is equidistant from A and B, possesses a right angle on midpoint. Now consider this line passing through P, M and making 90 degree with line segment AB. If I take any point on this line, same situation occurs. These two triangles are formed and they are congruent also because these two sides are equal. This is common side and there is 90 degree. Then I can say that these sides are equal. Therefore, any point on this line is equidistant from A as well as B. Therefore, the point can move only on this line because I have proved that the point which is equidistant possesses right angle and the point on this line possessing right angle are equidistant. Therefore, this point is allowed to move only on this line. Therefore, I can say that if my point P moves with geometrical condition, which was that it should be equidistant from the point A and B, then a path is traced. Here a straight line is traced. This is known as locus. The path is known as locus. Here I can say that the perpendicular bisector of the line segment AB is the locus. Therefore, locus is perpendicular bisector of line segment AB. Thus, this is the meaning of locus. Now, let's see what is equation of locus and how to find it. Let's see what is equation of locus. Equation of locus is a relation that exists between coordinates of any point on the path, and it holds for no other point except those lying on the path. Let's understood this definition. In the previous example, we have seen that locus came out to be a straight line, and we all know that straight line, the equation of straight line is of the form ax plus by plus c is equals to 0. And in graph it is drawn like this. This is the path, and therefore you can see that this is equation of straight line. It is a relation between x y. That any point on this straight line is denoted by x y, and it is a relation between the coordinate of the point on the path. Now if I take any point on this path x1 comma y1, it will satisfy this equation. But if I take any point that is not on the path, it will not satisfy the equation. Then it will be like that, like this. That ax2 plus by2 plus c will not be equal to 0. Thus, the equation holds only for points on the path, not for any other point. Now let's see how to find the equation of locus. I am writing the algorithm to find the equation of locus. Step 1. Assume the coordinate of point x comma k whose locus is to be found. Step 2. Write the geometrical condition involving write the geometrical condition in mathematical form. Involving this h and k. Then step 3 is eliminate the variables if any. And the last step is replace h by x and k by y, and then you get the equation of locus. Let's apply this algorithm into example. Now let's apply the algorithm to this example. This example says find the equation of locus of point which is at fixed distance r from a fixed point x0 comma y0 in the xy plane. If this is fixed point x0 comma y0, and we have to find the locus of that point which is at a fixed distance r, let's say point P. Now let's apply the algorithm. First step says that assume this point to be h comma k. In step 2 we write the condition in mathematical form. Here the condition is this distance is r. By distance formula I can write that distance between P and this center point C is h minus x naught square plus k minus y naught square is equals to r. We square the both sides. H minus x naught square plus k minus y naught whole square is equals to r square. We are not using this step number 3 because there are not as such variables involved in this question. In this another question, there will be variables and we will use step number 3. Now, use step number 4 which says replace x by k, h by x and k by y. Then the equation of locus becomes x minus x naught whole square plus y minus y naught whole square is equals to r square. And if we see what will be the locus in the geometrical form, then the path will be traced in the circle because any point on the circumference of the circle is at fixed distance r. Now see the path is circle and this is equation. Then we can say this is equation of circle. From the concept of locus, the equation of circles came to the picture. We will use this in the next example to visualize the locus of next example. In the previous example, we have not used the step third, which was eliminate the variables. In the example number 2, we will be eliminating the variables. Let's see the example number 2. The example number 2 says that if this is the setup, that a rod of length L is between these two perpendicular lines. Now situation is that this end point is sliding like this and this end point is sliding like this. When the road is sliding, then every point of the road is also moving. I want to find the locus of the midpoint of this road of length L. For that, let's apply the algorithm. First step, assume the point whose locus we find x comma k. Now, the geometrical condition which can be seen is that whatever may be the position of the road while sliding, the right angle triangle is formed. We can use the Pythagoras theorem. For using the Pythagoras theorem, let us assume this distance to be a and this distance to be b. Now I have introduced some variables. These are also variables because while sliding the road, a will also change, b will also change. We have to eliminate these variables. Now step number 2. I am writing this condition in mathematical form. By using Pythagoras theorem, I can say a square plus b square equals to l square. Now you can see that if this is length a, then this point is a comma 0, and this if this length is b, then this point is 0 comma b. Since this point is midpoint of this end point and this end point, then by the midpoint formula I can find this point. But h would be a plus 0 by 2 and k would be 0 plus b by 2. Then here I can get a is equals to 2h and b is equals to 2k. Now I am applying the step number 3, eliminating the variables. If I substitute a is equals to 2h and b is equals to 2k in this equation, then my variables are eliminated. Now I am solving it further. 4h square plus 4k square is equals to n square. H square plus k square is equals to n square by 4. And after using this step number 4, if I replace h by x and k by y, then the equation of locus will be x square plus y square is equals to n square by 4. If I compare this equation with the equation I have got in the previous example, it will be a equation of circle with center 0. If I write like this, and radius will be L by 2. Then in this example, the midpoint will follow the path of circle whose equation is given by this. The path will be like that, where radius is L by 2 and the center is 0, 0. Since we have understood how to apply the algorithms, let's do a genuine previous question. Since we have learned the concept of locus and how to find the equation of locus, let's apply it to solve the JMS previous question. This question has come in JMS January 2019. What does this question say? This question says that a point P moves on this line and there are also two fixed points. Let's draw the diagram according to the given information. Here is the line. It passes through 0, 4, 3 and minus 2, 0. And here is some point Q 1, 4 and some point R 3, minus 2. The point P moves on this line. Let's assume that point P is here. Assume it would be x1, y. If I join these points, then a triangle is formed. PQR. The question says to find the locus of the centroid of the triangle. Here would be the centroid C. As the P moves, the triangle also shifts and the centroid also moves. We have to find the locus of the centroid. Assume according to the algorithm the centroid to be h, k. Now apply the condition and write it and try to write in a mathematical form. To find the centroid of a triangle having 3 points, knowing 3 points, h would be x1 plus 1 plus 3 upon 3 and k would be y1 plus 4 minus 2 upon 3 because centroid the x coordinate of centroid is given by summing the x coordinate of the 3 points of the triangle divided by 3 and y coordinate is given by adding the y coordinate of the points of the 3 points of the triangle and dividing by 3. From here we can get the x1 in terms of h. H would be x1 plus 4 by 3 and k would be y1 plus 2 by 3. Here x1 would be 3h minus 4 and y1 would be 3k minus 2. Since this point x1, y1 lies on the line, it should satisfy the equation of the line. Let's put value of x1, y1 in place of xy in the line, in the equation of line. 2, 3h minus 4 minus 3, 3k minus 2 is plus 4 is equals to 0. Let's solve it. 6h minus 8 minus 9k plus 6 plus 4 is equals to 0. Then it would be 6h minus 9k and 10 plus 2 is equals to 0. Now replace h by x and k by y. Then the locus would be 6x minus 9y plus 2 is equals to 0. We have to take the option by finding the slope of this line. If the standard form of line is this, then the slope is given by minus a by b. So here slope would be 9 minus 6 by minus 9 would be 2 by 3. Therefore, examples option C is correct, 2 by 3. Thus, we have completed the topic locus.